Hi, this is Mrs. Wiederhold, and welcome to my lesson video on the discriminant. It's part of the quadratic formula. Let's get started. The discriminant is the part of the quadratic formula that is underneath the square root symbol. It is the b squared minus 4ac. Understanding the discriminant is important because it can tell us the types of roots that we are going to have, meaning the types of solutions, and how many. There are three types of roots that we can have. Number one, real and rational. These roots or solutions are the square root of a number that is a perfect square. For example, the square root of 36. 36 is a perfect square, so this would be considered a real and rational root. Number two, real and irrational. Now this is the square root of a number that is not a perfect square. There could be lots of examples of this. The square root of 5, the square root of 23, the square root of 50. All of these square roots have one thing in common. They are not perfect squares. So this type of solution would be considered real and irrational. Number three, imaginary. Okay, this is the square root of a negative number. For example, the square root of negative 36, the square root of negative 5. Because they are square roots of negative numbers, these solutions are considered imaginary. And if you were to see these on a graph, they would not touch or intersect the x-axis. Now let's see what the discriminant tells us. First, let's look at the discriminant that is greater than 0 and a perfect square. An example of this is 36. 36 is greater than 0 and it is a perfect square. So the number of roots you will have with a discriminant like this is 2. And the type of roots that this will be are real and rational. And I'm just going to abbreviate rational. Now, an example of this, there's lots of examples, but this is just one. We have 2 rational roots where the graph intersects the x-axis in 2 places. Now let's look at the discriminant that is greater than 0 but not a perfect square. An example of this could be 23. 23 is greater than 0, but it is not a perfect square. Now, with this type of discriminant, we will have 2 roots, and they will be real roots, but they are considered irrational because they are not perfect squares. And here again, I'm abbreviating the word irrational. Now, an example of this graph basically would be the same type of graph you would have if they were rational. They're real, so we're going to have 2 places where your graph crosses the x-axis. Now let's look at the discriminant that equals 0. There is only one example of this, and it is the number 0, if your discriminant equals 0. Now if this is the case, you will only have one root. And that root will be real and rational. And I'm abbreviating the word rational. An example of this graph would be where your parabola only touches the x-axis. It doesn't cross over it. Now let's look at our last type of discriminant, and that is when the discriminant is less than 0, meaning it's a negative number. So really, the example could be any negative number. I'll use negative 49, but it doesn't have to be the negative of a perfect square. It could be negative 23, negative 36, 25, whatever. Now, you will have 2 roots, but this time the roots are imaginary. And I'm abbreviating the word imaginary. The graph of this type of discriminant will look something like this. It'll be a parabola, and it will be above, or it could be below like that. In either case, the parabola will not touch or cross over the x-axis, and so the roots are considered imaginary. Now, I hope this video has helped you to understand just a little bit, hopefully, of what all the discriminant can tell us. So I look forward to working with you again. Bye-bye.